a stalactite, to drip, and meaning that which drips is a type of formation that hangs from the ceiling of caves, hot springs, or man-made structures such as bridges and mines. Any material which is soluble, can be deposited as a colloid, or is in suspension, or is capable of being melted, may form a stalactite. Stalactites may be composed of amberat, lava, minerals, mud, peat, pitch, sand, and sinter. A stalactite is not necessarily a speleothem, though speleothems are the most common form of stalactite because of the abundance of limestone caves. The corresponding formation on the floor of the cave is known as a stalagmite. Formation and type. Limestone stalactites, the most common speleothems are stalactites and occur in limestone caves. They form through deposition of calcium carbonate and other minerals, which is precipitated from mineralized water solutions. Limestone is the chief form of calcium carbonate rock which is dissolved by water that contains carbon dioxide, forming a calcium bicarbonate solution in underground caverns. The chemical formula for this reaction is Ca S 3 plus H 2O L plus CO Ac 2 Ca HCO 3 Ac 2. This solution travels through the rock until it reaches an edge, and if this is on the roof of a cave it will drip down. When the solution comes into contact with air, the chemical reaction that created it is reversed and particles of calcium carbonate are deposited. The reversed reaction is Ca HCO 3 Ac 2 Ca S 3 plus H 2O L plus CO Ac 2. An average growth rate is 0.13 ohm a year. The quickest growing stalactites are those formed by fast-flowing water rich in calcium carbonate and carbon dioxide. These can grow at 3 ohm per year. All limestone stalactites begin with a single mineral-laden drop of water. When the drop falls, it deposits the thinnest ring of calcite. Each subsequent drop that forms and falls deposits another calcite ring. Eventually, these rings form a very narrow, hollow tube commonly known as a soda straw stalactite. Soda straws can grow quite long, but are very fragile. If they become plugged by debris, water begins flowing over the outside, depositing more calcite and creating the more familiar cone-shaped stalactite. The same water drops that fall from the tip of a stalactite deposit more calcite on the floor below, eventually resulting in a rounded or cone-shaped stalagmite. Unlike stalactites, stalagmites never start out as hollow soda straws. Given enough time, these formations can meet and fuse to create columns of calcium carbonate. Lava stalactites, another type of stalactite, is formed in lava tubes while lava is still active inside. The mechanism of formation is similar to that of limestone stalactites. Essentially, it is still the deposition of material on the ceilings of caves. However, with lava stalactites, formation happens very quickly in only a matter of hours, days, or weeks, whereas limestone stalactites may take up to thousands of years. A key difference with lava stalactites is that once the lava has ceased flowing, so too will the stalactites cease to grow. This means that if the stalactite were to be broken, it would never grow back. The generic term livesicle has been applied to lava stalactites and stalagmites indiscriminately and evolved from the word icicle. Like limestone stalactites, they can leave lava drips on the floor that turn into lava stalagmites and may eventually fuse with the corresponding stalactite to form a column. Shark-tooth stalactites. The shark-tooth stalactite is broad and tapering in appearance. It may begin as a small driblet of lava from a semi-solid ceiling, but then grows by accreting layers as successive flows of lava rise and fall in the lava tube, coating and recoating the stalactite with more material. They can vary from a few millimeters to over a meter in length. Splash stalactites. As lava flows through a tube, material will be splashed up on the ceiling and ooze back down, hardening into a stalactite. This type of formation results in a very irregularly shaped stalactite, looking somewhat like stretched taffy. Often they may be of a different color than the original lava that formed the cave. Tubular lava stalactites. When the roof of a lava tube is cooling, a skin will form that traps semi-molten material inside. Trapped gases force lava to extrude out through small openings that result in hollow, tubular stalactites analogous to the soda straws formed as depositional speleothems in solution caves, the longest known is almost 2 meters in length. These are common in Hawaiian lava tubes and are often associated with the drip stalagmite that forms below as material is carried through the tubular stalactite and piles up on the floor beneath. Sometimes the tubular form collapses near the distal end, most likely when the pressure of escaping gas is decreased and still molten portions of the stalactites deflated and cooled. Often these tubular stalactites will acquire a twisted, vermiform appearance as bits of lava crystallize and force the flow in different directions. These tubular lava helictites may also be influenced by air currents through a tube and point downwind. Ice stalactites, a common stalactite found seasonally or year-round in many caves is the ice stalactite, commonly referred to as icicles, especially on the surface. Water seepage from the surface will penetrate into a cave and if temperatures are below freezing the water will form stalactites. Creation may also be done by the freezing of water vapor. Similar to lava stalactites, ice stalactites form very quickly within hours or days. Unlike lava stalactites however, they may grow back as long as water and temperatures are suitable. Ice stalactites can also form under sea ice when saline water is introduced to ocean water. These specific stalactites are referred to as brinicles. Ice stalactites may also form corresponding stalagmites below them and given time may grow together to form an ice column. Concrete stalactites. Stalactites can also form on concrete, and on plumbing where there is a slow leak and limestone in the water supply, although they form much more rapidly there than in the natural cave environment. The way stalactites form on concrete is due to different chemistry than those that form naturally in limestone caves and as the result of the presence of calcium oxide in concrete. This calcium oxide reacts with any rainwater that penetrates the concrete and forms a solution of calcium hydroxide. The chemical formula for this is CaO, S, plus H, 2O, L, a Ca, OH, Ac, 2. Over time this calcium hydroxide solution reaches the edge of the concrete and, if the concrete is suspended in the air, for example, in a ceiling or a beam, then this will drip down from the edge. When this happens the solution comes into contact with air and another chemical reaction takes place. The solution reacts with carbon dioxide in the air and precipitates calcium carbonate. Ca, OH, Ac, 2 plus CO, G, 2 a Ca-CO, S, 3 plus H, 2O, L. When this solution drops down it leaves behind particles of calcium carbonate and over time these form into a stalactite. They are normally a few centimeters long and with a diameter of approximately 5 m. Records. The White Chamber in the Jata Grotto's Upper Cavern in Lebanon contains an 8.2 am limestone stalactite which is accessible to visitors and is claimed to be the longest stalactite in the world. Another such claim is made for a 20 am limestone stalactite that hangs in the Chamber of Rarities in the Gruta Rei do Mato. However, vertical cavers have often encountered longer stalactites while exploring. One of the longest stalactites viewable by the general public is in Pollinane, County Clare, Ireland, in a karst region known as the Burren. What makes it more impressive is the fact that the stalactite is held on by a section of calcite less than 0.3 am2. Origin of the term, stalactites are first mentioned by the Roman natural historian Pliny in a text which also mentions stalagmites and columns and refers to their creation by the dripping of water. The term stalactite was coined in the 17th century by the Danish physician Ole Worm, who coined the Latin word from the Greek word ifloron ii plus or minus ii plus or minus iiiy and the Greek suffix iii, photogallery. See also, stalagmite, livesicle, rusticle, cast, icicle, bottlebrush, stalactite coated with pool spar. Brinicle, references. Dripstone in time-lapse, Schmidtkens, B. Wittke, G. Chemiunserazit, 2006, 40, 246 doi, 10.1002/use 200,600,370. External links, the Virtual Caves page on Stalactites, Stalactites by Enrique Zimi, Wolfram Demonstrations Project.